Hello, Vulnerables. It's been a while since we've been together, and but I usually want to pick out a video that I think really could possibly better explain and maybe give you some shortcuts that will help you along the way as you try and solve certain types of problems in Algebra 1. Now, the problem you see in front of you, there are four of them, and they involve factoring. They're factoring two quadratic, or we're factoring quadratic trinomials. What's different about today versus yesterday is that today we no longer have a leading coefficient of 1. Now we have a leading coefficient of a number other than 1. In this case, there's a 3, a 5, a 2, and a 7. Now, what's special about these leading coefficients is that they're all prime numbers. And I'm showing this because I saw some students factoring this way, and I thought I would share what they know so that we all know a little bit about this. Now, if you don't like this method, I'm going to show you another method on my second video, which you can get to. And there's another way you can do it, and you can do all the problems that way. You don't have to do it this way unless you're trying to do maybe a little bit quicker. So what we have here is, I'll look at the very first problem. It's 3x squared minus 10x plus 7. And we want to factor it. And the fact that we have the leading coefficient being a prime number, that's huge. Because what that allows us to know is that we know when we actually do the factoring, we are going to have in our two binomials, only choices are 3x and x. That's the only way that it can go. All right, so that's a big part of the job. Now, this is what I've seen students do. They've gone here and they said, they put a little x here, and they put the 3x here, and they put the x here, off to the right. And then they write down the choices. So I can have, since it's going to equal product of 7, and the sum is negative 10, that means both the numbers are going to have to be negative. So either I'm going to have negative 7 and negative 1, or negative 1 and negative 7. So let's take a look at the first set first, the one that's up top, and see if that's the right one. And the way we check it is, you see how this negative 7 here on the bottom left is connected up to the x? We just check and see. That would be negative 7x. And if I go this way, that would be negative 3x. That means negative 7x plus negative 3x is negative 10x. Then I've got it right. So when I finish my factoring, I just need to put the 3x and the minus 7 together, and I put the x and the minus 1 together. And I'm actually finished. I mean, I've actually factored that trinomial. And if you want to check it just to make sure, I'm going to put a little green lines on the oi, on the outers and the inners. Actually, they're purple here. It's a green pen, but it's purple mark. And you'll see that that's negative 1 times 3x gives me the negative 3x, and negative 7 times the x gives me the negative 7x. Add them together, you get the negative 10x. Now, what you would find, I just randomly guessed those two. If I'd guessed the other one first, let me go through and just show you this. If I'd guessed this one instead, here's what would have happened. I would have multiplied negative 1 times x, and I would have had negative x. Negative 7 times 3x, I would have had negative 21x. That adds it up to negative 22x. So that one would not work. And so I would just say, try it the other way. But it just so happens we guessed it right the first time. So let's try the next problem and see what we can do with this one. All right, so we look at the next problem. We're looking at 5x squared plus 28x plus 15. So once again, the leading coefficient is prime. So my only choices this time are going to be 5x, and they're going to be x. And when I look at this, it looks to me like since the product has to be positive 15, and they add up to 28, they're both going to be positive. So let's continue that little x method that I showed you previously. So I put 5x and x. Now what's a little tougher about this is that 15 has multiple factors. So I could do 15 and 1. I could do 1 and 15. I could do 3 and 5. I could do 5 and 3. So I'm going to go through, I'm going to check these and see how it actually works and see which one will give me the right factoring. So I'm going to erase a little bit of this other work off to the left. So let's start with the first one, 15 and 1. And the stuff that I'm writing down right now, you can actually do this in your head. Many of you can. And since the product is positive 28, that means they're all going to be positives here. So if I check the first one, I get 15x plus 5x. No. So let's try the next one. All right, let's try 1 and 15. So that's going to get, ooh, that's way off, because I'm going to have 1x, and 5 times 15, I think, is 75x. That's way off. So that's a big no. So let's try another one. I'm going to pull the black pen out. Let's come down and try the 3 and the 5. So 3 times x is 3x. 5 times 5x. Uh-oh, this looks good. So that's 28x. So the answer is yes. This is the one I'm going to use right there. So that means I have to line up the 5x with a 3. So it's going to be plus 3, and then x plus 5. So I have x plus 5. And again, I'll pull the green pen out, or I think it's the purple pen actually here, if just to show you that I'm talking about. I mean, the first terms are obviously 5x times x is 5x squared. The black terms at the end, 3 times 5 is 15. And if you look at the purple outers and inners, you get 25x because 5 times 5x is 25x. And the other one is going to be 3 times x, which is 3x. So I'm done. All right, so it looks pretty good. All right, I've got 2 more problems to show you in this video. So I'm going to work my way down so you can get a little farther down the page. And I'm going to go a little more quickly through these next ones. Oh, I went off the page, so I'll scroll right back. There we go. All right, so once again, I have a prime leading coefficient. So this is set up real nicely. So it's going to give me 7x and x. And let's see what I have here. So I do put my x here. I have 7, and I have 1, or 7x actually, and 1x. Now what's different about this also is you notice that the product has to be -6. So I need to make sure one of them is negative. So I've got 3 and -2. I'm not going to worry about -3 and +2, and I'll explain why in just a second. But then I'm going to do, I'm going to put the -2 on the left-hand side and the 3 on the right-hand side. And I could also have 6 and 1, or actually should be 6 and -1, and then -1 and 6. So we'll see what happens in just a minute. We'll see if I actually have the signs correct in the correct spot or not. So I'll start with the very first one, 3 and -2. Let's see how lucky I was with my guessing. So I do 3 times x on the cross. That gives me 3x. And then I get -2 times 7x is -14x. That equals -11x. That's no good. So that one, bad one. So come to the next one. Let's do -2 and 3. So I'll go -2 times x is -2x. And do the next cross, 3 and 7x. That's going to give me plus 21x. Add them together. How about that? -2x plus 21x is 19x. So it looks to me like that is the correct one. So my best choice is the second one down. That means 7x goes with a -2, and x goes with a +3. Now I need to show you something. What would have happened that instead of doing -2 and 3, how about if I had done 2 and -3? What would you done at this point? Because this time when I do the x across, I would get 2x. And then I would come here, I get 7 times -3 is -21x. Well, that equals -19x. That's not wrong. It's just the signs that are in the wrong spot. So if you do this on the cross method and you get -19x instead of a positive 19x, that just tells you the signs were wrong. So instead of doing 2 and -3, you're going to do -2 and +3. Pretty simple that way. You don't have to look. It's not a wrong answer. It's just the signs are incorrectly placed. So you can fix that very, very quickly. All right, now we're going to do the last problem. The last problem is a little bit trickier. And let me get this back up here. I'm not going to go back and start over again. So let's take it the last problem. I'll erase a little bit of this work out of your way. So now we're looking at 2x squared minus 9x minus 18. So once again, we know we're going to have 2x, and then we're going to have x, but we're not sure what's going to come next. So I'm going to do my little cross. I've got 2x and x. So now I need to come up with all the factors of 18. Yikes. And since it's a -18, one of them is going to be positive, one of them is going to be negative. So there's one. Then I have to switch it around. Then I have to do 9 and 2. I'm sorry, should make it 9 and -2. And then -2 and 9. And then the last one would be 6 and -3. Be -3 and 6. Okay. Now I'm going to give you another little hint here that will help you and understand why certain things will never actually work and why they shouldn't come here. If you come back to the original problem, you'll notice the greatest common factor here has to be 1. The greatest common factor equals 1. So this should help you figure out some of the things that you're not going to use. For instance, I would not use this one because if I use this right here, if I chose this one as being my answer, I would have to have 2x plus 18 times x minus 1. But if you notice on the very first binomial, the greatest common factor equals 2. So it's impossible. If I have a greatest common factor of 1 earlier, I can't now suddenly have a greatest common factor of 2. So I can immediately eliminate that one and know that is not going to work. So I'm going to X that one off here because the greatest common factor of 2 and 18 should be 1, and it's not. So if I work my way down my list, you can see there's actually 2 other ones that I can immediately get rid of. And it's going to be this one right here, because I can't have a 2x and a negative 2, because that would be a greatest common factor of 2. And then I can't have this one either, because you've got a 6 and a negative 3. So I can cross these 2 plus the initial one off. So really I only have 3 of these that I actually have to check. So I'm going to start with the top one. And let's see what I've got going on here for the top one. I put my x in. Let's see, if I multiply across, that's going to give me 2x times 18. That's 18x. I'm sorry, that was all totally wrong. 2x times 18, that was wrong. Should be 36x. Yikes, I'm getting way away. I'm supposed to be at negative 9. I'm nowhere near that. And negative 1 times x is negative x. No way. There's no way that one's going to work. So let's put an x on that one. And let's try 9 and negative 2 now. So if I do 2 times negative 2, that's negative 4 on the x. And if I do 9 times x, that's 9x. That's going to equal 5x. Okay? That's no good either. It's supposed to be negative 9x. That's what I'm looking for. So my last hope is the last problem. So let's try that one. So if I do 6 times 2x, I get 12x. And negative 3 times x, I get negative 3x. Add them together, I get 9x. Now, if you remember, that's good because I want to get 9x. But if you notice in the problem, I want to get negative 9x. No big deal. All that means is that instead of doing negative 3 and 6, I'm going to make it positive 3 and negative 6. So my factored form would be 2x plus 3 and x minus 6. And if you check the outers and the inners just to make sure that you really have it correctly, you'll see that's my negative 12x, my positive 3x. So this is just an example. As you get really good at factoring, you might want to consider doing this type of factoring when the leading coefficient is a prime number, like 2, 3, 5, 7, 11, and so forth. In a minute, I'm going to go through another example when the leading coefficient is a composite number, such as 4 or 6 or 9 or 12 or 15 and so forth. All right, thank you very much, and that's the end of the very first video.